Okay, we're in section 29 of the notes. This is the section on relations and functions. I know this is rather abstract. We did cover it in class though. There's videos also here if you need to reinforce what we said in class. You could also read through this. We try to say that visually it's going to be a little bit easier to deal with than verbally, but for the most part, they're going to be simple problems and our visuals are going to help us answer these questions. I do recommend reading this over and over again to try to make some sense out of it. It's difficult though. The other thing we mentioned was, the domain never divide by zero. The domain is the allowable x values, never divide by zero, something to look out for. We went through a bunch of examples. Hopefully they were well understood. If for whatever reason, including your spacing out what was going on, you can rewatch the videos for that or rewatch the entire lecture, whatever works for you. But you need to master this material. You need to study it. You need to master the material. And then, of course, at some point you say, well, when do I get to try this? Well, by doing the homework. All right. So, eventually we'll get to the section where it says homework. You're expected at this point to have actually read through the notes, attended lectures, of course, and made sense out of the material. All right. And then you say, well, I want to try. And that's the point we're at now. We're going to try the material now. We're going to go through it one problem at a time. So I'm going to do another share with you. Just give me 1 second. And I'm going to do a whiteboard with you. Okay, so where are we? You should have the notes in your hands, and you should have your notebook with the worked out solutions to these problems. But we're in section 29. And we're doing the homework. Now, if you've not studied or done the homework, this is going to seem like it's going to move pretty quickly. Let's do number one. It says stay with the relation, and I'll tell you what the relationship is. There's a set of ordered pairs, and the ordered pairs, I'll write them down for you, is 5 comma minus 2. That's a relationship. It says 5 is related to minus 2. It goes on to say 6 minus 1, and it goes on to say 7, 0, and it goes on to say 8 minus 2. All right. Now again, we're going to do bubble diagrams, and we're going to put the x values here. This is what's known as the domain of the problem. And the domain, these are ordered pairs, is going to be x, and then the range of this thing is going to be y. Let's write this down. What are the x values we say? 5, 6, 7, and 8. We'll put another bubble down. These are two sets. This is a set of y values. We're going to call this the range. All right. Now what goes over here? I just put the numbers in the y's. What do I say? Minus 2, minus 1, 0. Now someone says I see minus 2 again. I'll put on a mean by that. Minus 2, minus 1, 0, minus 2. Well, we say minus 2. It's there. It's there, it's there, here. All right, like seeing me twice. Same guy, minus 2. All right, now I'm going to put my arrows in. And the relationship 5 is related to minus 2. 6 is related to minus 1. 7 is related to 0. And 8 is related to minus 2. Okay, what I'm looking at over here, though, for this to be functional, I got to make sure that everyone in X has a relationship with somebody in Y, and that's true. The one thing I really need to look out for, though, whatever is in X, only one arrow can be coming from each member in X. Let's take a look at that. 1 arrow from 5, 1 arrow from 6, 1 arrow from 7, 1 arrow from 8. So I'm going to say this is functional. All right. What they want me to do is state, is it a function? It's functional. The answer is yes. Yes, it's functional. Look at the key. What does it say? Yes. We're feeling good about that one. Let me go to number 2. What does number 2 say? Well, again, it's one of those relationship problems. So instead of me writing down all the points, I'm just going to put my bubble diagrams down now. X goes here, and Y goes here. Domain and range. Well, I'm going to look at the X's, and I'll tell you what I'm seeing in the order I'm seeing, by the way. 5, and then I'm seeing 3. I'm just writing numbers I'm seeing. 7. Again, you have to be looking at the notes to know that. 8 and 3. All right. Now someone says, can you put 3 down twice? I'm seeing him there. He's 3. He's there. 3 is there. Right? 5 is there. 3 is there. 7 is there. 8 is there. If you think 3 there is twice, he's not there twice. Just like if you see me twice during the day, it's still me. All right. This is Mr. 3 at this case. Now we're going to put down the range now. And what's it going to be? I'm looking at the numbers. -2, 1, -3, -1, and 2. All right. I'm going to take my arrows in now. I'm looking at them. I'm not trying to memorize. 5 has a relationship with -2. 3 has a relationship with 1. 7 has a relationship with -3. Just connecting them up. 8 has a relationship with -1. Last but not least, 3 also has a relationship with 2. Okay, let's go through this. Does everyone in that set X of domain have a relationship? And they do. 5's related, 3's related to somebody, 7's related to somebody, 8's related. That's all good. Here's the problem. 3 is violating the rule because only one arrow can come from these guys. So 5 has one arrow, 7 has one arrow, 8 has one arrow, but 3 has 2 arrows. So this is not functional. If someone asked you why it's not functional, you would say 3, who's in the domain, has a relationship with 1 and with 2. Not allowed, right? Not functional. All right. So look at the key, and of course they clearly say that. They say no because an element in the domain 3 maps to 2 different elements, 1 and 2, in the range. All right. So it's not functional. All right, let's go to number 3. It's rather abstract concepts, functionality. Number 3 says given. This is functional notation. It's read as f of x. F of x is equal to minus x squared minus 3x plus 1. What they want me to evaluate is f at minus 1. What I recommend, parenthesize the variables. We've been doing this for a long time. And plug in the value. Let's do the first term, minus 1. Second term, plus 3, plus 1. What does this give us? 3. What do we recommend you do? Look at the answer key to make sure you're matching that. All right, let's go to number 4. And number 4, I'm reading it to you, is now g is a function of x. What is it? It's x minus 1 over x squared plus 1. What do they want me to do? G of minus 3. Again, what I recommend, especially if you're struggling with this, parenthesize the variable and then plug it in. Well, what do you get on top? Minus 3 minus 1, which is minus 4. On bottom, you can get 9 plus 1, which is 10. You should reduce that to minus 2/5. Look at the key. And if you're not staring at that, something's wrong. And you should be staring at that, minus 2/5. All right, let's look at number 5. Again, I'm going to put the bubble down. You don't have to if you don't need to. I'll put this over here. This is x, or the domain. And I'm going to put down y also called the range in this case. All right. So let's take a look at this. I'm looking at it, and it's number 5. So I'm going to write the numbers down. So you see 3, I see 2, I see 1, and I see 5. All right, now let's put the range numbers down. -5, 7, -1, and -3. Put the relationships in. 3 is related to -5. That's their connection. 2 is related to 7. That's their connection. 1 is related to -1. That's their connection. And 5 is related to -3. That's their connection. This is -3, by the way. All right, what was their question, though? By the way, this is definitely functional. Every element in the domain has one arrow coming from it, which is good news. All right, their question is, what's the domain? I'm going to write it down as a listing. And what do I see? 1, 2, 3, and 5. That's a listing. Let's put the range down. What's the range down? I'm going to put it down as a listing. -5, -3, -1, and 7. All right, let's look at the answer key. Make sure we're getting those things. In other words, we're getting the domain and are we getting the range? Mistakes can happen, by the way. So let's take a look at it. I got 1, 2, 3, 5. Got that one right. -5, -3, -1, and 7. All right, let's keep going. Let's go to number 6. And again, if it's going too quickly for you, may not have studied or done the homework yet, you can always come back at a later time and rewatch these videos. They'll be published and available to you throughout the semester. So I'll write down g of x, and g of x is minus, it's a rational function. And what does it say? It says, what values are excluded from the domain? Well, you have to realize here that I'm going to say this is the trouble over there. And what did we say about this? You can't divide by 0. So then the big question is x plus 3 ever equal to 0? And it is when x equals -3. So that's bad news. So what value is excluded? -3 is excluded. All right, it's the only number of all the numbers in the universe that are not allowed into this function. You can't put -3 in. And why is that? Division by 0. Again, look at the key and you'll see it says -3 is being excluded. All right, so let's keep going. I'm going to do number 7. And when I put number 7, I'm going to push this up. I'll write 7 down for you. 7 is a function, and it's k of x is a rational function, and it's 3 minus x over x squared plus 1, right? They tell me the domain are these numbers here. I'll write them down for you. -2, -1, 0, 1, and 2. Their question is, what's the range? All right, so we're given a domain, what's its range? Well, the way I'm going to do this is just evaluate the function at those values. So I want to do k of -2. I want to do k of -1. I want to do k of 0. I want to do k of 1. And I want to do k of 2. I'll be honest, I'm getting a little better at this. So what I'm going to do is just concentrate on doing the computation. I want to do the top first, though. The top is 3 minus x. I'm going to do one at a time, starting at the top, right? That's -2. So 3 minus a -2 is 5. Do the next one. 3 minus a -1 is 4. 3 minus 0 is 3. 3 minus 1 is 2. There's a nice pattern to this, isn't there? 3 minus 2 is 1. That's a top number. Let's do the bottom number now. What are you doing? You're squaring that number and adding 1 to it. So when you square -2, you get 4. 4 plus 1 is 5. This gives me 1. Let's go to the next one. What's the next one going to be? -1 squared is 1, and 1 plus 1 is 2. Let's do 0. You get 1. This gives me 3. Let's do 1. What do you get? Well, 1 squared is 1. 1 plus 1 is 2. What do you get? 1. Let's keep going. Let's do 2 now. It's on the bottom, by the way. What do you get? 4 plus 1, which is 5. So now I know my range. I'll write the numbers down for you. I'm kind of looking at it, and the smallest number there, I like to write in order, by the way, is 1/5. That's taken care of. What's the next number I see? 1. What's the next number I see? 2. What's the next number I see is 3. All right. I'm going to look at the answer key. And I want to point out, some of you might be confused by this. It's the same thing. They just put the number down 1 twice, by the way. You can put down as many times as you like, but it looks kind of odd. Here's the deal, though. It's nice just to write it in the most compact, orderly way. And this is the most compact, orderly way. What's written there is not incorrect. They write down 1/5. I see the 1, I see the 2, and I see the 3. All right, let's go to number 8. And number 8 says, what values are excluded? I'll write this down. And what do you have here? X minus 2 over 9. Well, here's the deal about this one over here. There is a division. There's no doubt about it. But 9 is never equal to 0. So there are no numbers that are being excluded. So I'm going to say none. Nothing's being excluded. Look at the key and agreement with that. Let's go to number 9. And number 9, very similar question. It says, find the range. I'll write the function down for you. The function is 2x squared minus 3x plus 1. They give me the domain values. I'll write them down for you. F of minus 1, f of 0, f of 1, f of 2, and f of 3. I'm going to compute each one separately. And again, I'm getting better with the evaluation. If you need to print size variables, plug it in, that's fine, you can do that. So you get 2 plus 3 plus 1, which is going to be 6. Next one's going to be 1. That was simple. Next one's going to be 2 minus 3 plus 1. Let's see, that's going to be 0. Next one is going to be 8 minus 6 plus 1, which is 3. If you did 3, what do you get? 18 minus 9 plus 1. And what does that give you? 10. So I'm ready to write down the range. Smallest number I see there is 0. Then I see 1. Then I see 3. Then I see 6. And then I see 10. Now, see, the deal is, could I have made a mistake in the computation? Of course. What I want to do is I want to look at the answer key. Let's take a look at it. And again, they run in different order. 6, 1, 0, 3, and 10. We're good to go. All right, let's go to number 10 now. And they give me f of x equals 2x. Whoops, made a mistake. 2x minus 3. A, f of 1. That would give me 2 minus 3, which is minus 1. We'll check it in the key later. B, f of minus 2. That would give me minus 4 minus 3, which is minus 7. Again, we'll check this in the key later. C, what does C say? F of A. Well, that seems strange, but what do? Just plug it in. That's done. It's 2a minus 3. Let's go to D. What's D is f of 2x. It seems strange, but I'm going to plug it in. 2, parenthesize the variable, 2x. What does that give me? 4x minus 3. Let's go to E. What does E state? F of x plus 1. 2, parenthesize the variable. Looks pretty easy to do. 2x plus 2 minus 3 is 2x minus 1. Again, we'll check the key later. Let's go to F. This is a long problem, isn't it? That's f of x plus h. 2x plus h minus 3, which is 2x plus 2h minus 3. How much I can do about that? Let's go to G. It's getting more complicated. F of x plus h minus f of x. Well, I've done f of x plus h. That's 2x plus 2h minus 3. Now, what do they want to do? Subtract away f of x. Well, it's going to be minus 2x minus a minus 3 is plus 3. What does this give me? Well, a lot of things disappear. The 2x disappears and the 3 disappears. You're left off with 2h. Let's do the last one, which is h. It's f of x plus h minus f of x over h, but they go on to tell you that h is not equal to 0. Well, that's good because I couldn't divide it or where. What do you get here? Well, we already done the top. It's 2h, and the bottom is h. Well, if h is not 0, this reduces to 2. All right, I'm going to point out, you really want to look at the answer K. I read it, mistakes happen. Let's go back over it. Minus 1, minus 7, 2a minus 3. Let's look at the answer K. 4x minus 3, 2x minus 1, 2x plus 2h minus 3, 2h. Whoops, I forgot to put a box on it. I think we're done. Oh, no, I'm sorry, we're not done. There's another problem there. I'm sorry about that. The last question, which was h, and that says 2. All right, we did it. All right, I'm going to go back over and to that SAGE thing, that optional stuff we're trying to introduce you to programming. I'm going to switch and share into the screen with you. And again, I realize some students, they don't want to deal with this. We're not saying you have to, by the way, but for those students who want to move forward into a STEM-related career, we would recommend at least trying to get your feet wet in coding, all right? So I'm going to launch the SAGE Math again, and I'm going to CoCalc. Give me 1 second here. And, oh, you know what? I had the other sheets open there, so I don't have to launch that again. So let me just back up over this. I'm going to delete it out. It's like a word processor, so I can do that. I'll just select all, delete. There you go. A little bit quicker than just, oh, let's do this, reset. Seen this before, right? This looks bad. A, comma, B, comma, S, comma, X. There's 4 variables, right? 4 variables now. And I'm going to say the variables, VAR. And let's type this in, back what I'm seeing. A, B, right, S. Don't worry, if I type wrong, it'll tell me. And X. Shift, return. All right, it's working. See that? A little slow. We're using other people's computers. That's why it's slow. All right, let's do this f of x business. F of x. Now, when I use 1 equal sign, it's an assignment operator. And I'm going to assign f of x, x squared, minus 3 star x, plus 1. Shift, return. It's working on it. All right, let's do f of minus 1. It's working on it, by the way. It's not going to put a result down until it works on it. And yet little red things blinking at you right now. Basically, they're trying to get a computer to actually do the code I gave it. And it's going to give them the code, and it's going to do those lines one at a time. Let's give it some time. And that's the worst thing about using other people's computer resources. They may not give you resources. You might have to sit there for 10, 15 minutes before it does that. Of course, if that happens, I'm going to have to switch over to another product to do the problems. It's still working. Let me just, I might have to start again. I'm just hitting shift enter again. Oh, there it goes. It finally did it. Okay. So let me keep going. F of S. Now that's not so surprising. F of 2x. Remember, if you do multiplication, you have to put it in. It does it pretty quickly, right? F of A plus B. These are things that we've done in class already. Gee, it did that, okay. Here's the deal though, it didn't expand it. So I'm going to do that command again, f of a plus b. Whoops, I'm sorry about that. But I want to expand it. Whoops, I keep doing it. Dot expand. This is so much like Python, all right? Wow, they expanded it for me. And we've done that in class before. I'm getting a little tired, so I'm gonna type this in. It's something we've done in class, by the way. Shift return. It didn't do much. So what I'm gonna do is that again, I'm gonna expand it, see what happens. Still didn't do it. So I'm gonna look at what they said. And they said, I bet they said, yeah, factor, look at that. Let's do that again. I'm gonna go back over here. Just, I'm gonna type it in. I'm just gonna type in the word factor now. Wow, it's still not doing it. You know what I'm gonna do? I'm gonna get a Wolfram. I'm gonna see if I can do it in Wolfram. Hey, you know what? I'll leave that as an exercise for you to do it in Wolfram. But this really didn't do much, right? Came back to the same answer I got over here. You know, maybe I'll do dot expand too. Okay, let me try simplify. Yeah, still doing the same stuff. All right. Okay, so I'm going to call it quits, and that was just a short introduction to using. Oh, I think I see what I've done there, and it's a good thing I noticed that. And let me just do that. I didn't type it in the same way. Oops. Let me see if I got it right. F of A minus B. There's a line. Oh, there's an error now. Let's see what I did wrong. F of A minus F of B. I see it now. Not matching up my parentheses there. There it is. I'm sorry. So you realize it was able to do it. I typed it in wrong. It does happen sometimes to me. I type things in wrong. I want to point out this is a problem that we've done in the notes. Let me go back to it. And I want to point out where that was. I know it's difficult. A lot of people can't remember what's been done, but we did this class of problems over here. The last one being, f of A minus f of B over A minus B. It was tough. You remember that from class, but it turned out in the end it was A plus B minus 3. Okay? Thank you.